civilizations in the observable universe. Moving back to just our galaxy, and doing the same math on the lowest estimate for stars in the Milky Way, 100 billion, we'd estimate that there are 1 billion Earth-like planets and 100,000 intelligent civilizations in our galaxy. SETI, Search for Extraterrestrial Intelligence, is an organization dedicated to listening for signals from other intelligent life. If we're right that there are 100,000 or more intelligent civilizations in our galaxy, and even a fraction of them are sending out radio waves or laser beams or other modes of attempting to contact others, shouldn't SETI's satellite dish array pick up all kinds of signals? But it hasn't. Not one. Ever. So where is everybody? Proposed solutions to Fermi's paradox fit into 3 broad categories. 1. They're nowhere, and know when. Aliens don't exist, and they never have. This scenario might have seemed more likely in the universe imagined by Aristotle and Ptolemy, a small assortment of celestial orbs spinning around a singular Earth. But that isn't the universe anybody lives in. The more we learn about the universe, the more absurd it would seem if all but one of those bodies were bereft of life. So this is both the least likely answer to Fermi's paradox, and the only one that fits all the evidence currently available to astrophysicists. 2. Life is out there, but intelligence isn't. Scientists predict that we'll find evidence of simple life on Mars, or a faraway moon, within the next 10 to 30 years. But they're imagining something more like microbes or algae, not underwater cities in the liquid methane lakes of Titan. This shifts the question from where is everybody to a more sophisticated query. What precisely is keeping an infinitude of dumb molecules from assembling to form an abundance of intelligent life? 3. Intelligent life is abundant, but quiet. This possibility, known as the zoo hypothesis, invites some of the strangest speculation. Maybe humanity is still so basic and primitive that advanced civilizations don't think we're worth talking to. Or maybe those other civilizations have learned that broadcasting their existence leads to extermination at the hands of violent intergalactic colonizers. Or maybe our solar system just happens to be located in a quiet, ex-urban cul-de-sac of the universe, an accident of cosmic geography. But none of these theories hold a candle to my favorite conjecture of all, slumbering digital aliens. No matter what the true answer is, we are still alone in the whole universe. Hello? Is there anybody out there? Do you have any guesses why no one is getting in touch with us? Please share them in the comments. Share the video with your friends, and remember to click subscribe to be among the smart and the sexy.
Space is the worst. It's got hostile radiation, a total lack of atmosphere, near absolute zero temperatures, problematic gravity wells, and worse, no extension cords. In order to keep your spacecraft alive in that environment, you'll need electricity to keep it warm, not to mention all the power to run scientific instruments and the transmitters to send that data home. Getting enough power in space is a big problem. There are 3 ways of generating power in space: solar panels, radioisotope thermoelectric generators, and nuclear fission reactors. Each have their pros and cons. Let's start with solar panels. Now, this technology has been around for decades and works by using photons from the sun to knock electrons free from atoms. Those electrons are harvested and provide electricity for a spacecraft to operate. Solar panels need to be big to supply usable energy to a spacecraft. The International Space Station's 8 solar arrays contain thousands of solar cells and take up an area half the size of a football field. Its arrays can produce up to 120,000 watts of energy, enough to power 40 homes. Solar panels designed to fly in space are much more expensive than ground-based panels because weight and volume on the spacecraft are at a premium. They use high-efficiency cells. Space agencies have pioneered many of the technologies used in solar panels. The European Space Agency recently announced that they enabled a very thin solar cell, just 0.1 millimeters thick that provides 30% efficiency by sandwiching together 4 different layers of materials and can absorb wider wavelengths of sunlight. The most efficient panels on the market today only convert about 22.5%, and most are in the 15 to 17% range. NASA's Opportunity rover set down on the surface of Mars back in January 2004. It's now spent more than 5,000 days exploring the red planet, searching for evidence of past water. At night, Opportunity experiences temperatures that go as low as minus 105 Celsius. No matter what happens,